so this is the last thing you have to watch while I'm away, and this is under optimization. Okay, so optimization, again, we did last year, and with optimization, the biggest thing is I can't give you guys like a set way of doing it. It's all just problem solving. You've kind of got to work it out by yourself. But I'll give you an example. So here's our example. So it's infinitely many rectangles can be inscribed in a semicircle of diameter 20 centimeters. Find the shape of the largest rectangle. Okay, so we've got our semicircle and with optimization. The first thing you should always kind of do is, if you can, draw what it's going to look like. So we've got a semicircle, diameter of 20 centimeters, and we've got a rectangle. So we'll call the length of the rectangle x, and we'll call the height y. Okay, so we want to find the shape of this rectangle that's going to be the biggest. Okay, so this is a circle, so we know that any point from the middle of the circle outwards, if this has a diameter of 20 centimeters, the radius is going to be 10. So we know that this here is a radius of 10. And we can use, if we know that this is y and this is 10, we can use Pythagoras, because it's a rectangle, to make an expression for this area here. So we're going to have c squared equals a squared plus b squared. 10 squared equals y squared plus, we'll call this one m squared. Okay, so m squared equals 100 minus y squared, and m is going to be the square root of 100 minus y squared. Now, because this is the length, we don't need the plus minus here. Okay, so from here, this is the first part. M is going to be half of x. Okay, so x is equal to 2m. Ooh, that's really big. X is equal to 2m, so 2 lots of square root 100 minus y squared. Okay, so we've got our x value, which is 2 lots of 100 minus y squared, and then say we want to find, we're looking at the largest rectangle, so the biggest area is going to be where we've got x, which is 2 square root 100 minus y squared, all times by y. So length times by width. Okay, and we can simplify that to say that's going to be 2y square root 100 minus y squared, like that. Alright, I'm just going to clear this screen and rewrite that. So area equals 2y square root 100 minus y squared. Now, the biggest thing with optimization problems is we only want to have one variable in our equation. So that's what we were doing by using the Pythagoras, is we want to be able to eliminate, so we don't have two, both an x and a y variable. We just want to have one. And if we have two, then we'd have to do what's called implicit differentiation, which doesn't really work. Alright, then this is an optimization problem. So this is telling us that, again, say this is our function, our optimal point is going to be either our highest point or it's going to be our lowest point. And both of those are going to be where our derivative is equal to 0. Okay, because again, maximum or minimum. So we've got to find then our derivative. So dA on dy, dx, dy on dA, write that out, dy on dA. For this formula here, we're going to be using product rule. Okay, so we have uv dash plus vu dash. So u is 2y, v is 100 minus y squared to the power of negative a half times by negative 2y, plus v, which is square root 100 minus y squared times by the derivative of u, which is just going to be 2. Okay, and if you wanted to, and if you need to write it out, do it at the top to find it. Okay, but I'm just trying to save time. Alright, 2 and the half cancels, we're left with negative 2y squared, and that's 100 minus y squared to the power of negative a half, plus the square root of 100 minus y squared times 2. Okay, from here we need to find where our derivative is going to be equal to 0. Okay, and this is just going to, we are going to put this into our calculator. Okay, like I said, I don't have calculator software on my computer. So what I'm going to do, just give me a second, I'm just going to try and rearrange this a little bit. Alright, so I tried to rearrange it and it did not work at all. So what I'll do is I'll have to make another video just to show you how you would plug that into the calculator and find a solution. So watch the next one to get the answer. I'll have to do that off my laptop, not this one. But that's alright. Anyway, I hope you guys are having a lovely week, and yeah, this is the last thing that we have to do until I come back. So I hope it's been okay and that you're managing reasonably well. Alright, okay, bye.